So my name is Chris Grigori. This is handling async tasks in LiveView with Style and Grace. I'm a staff engineer and tech lead working at a company called Multiverse, and I've been working with Elixir professionally for about 5 years now. I'm also from London, so I'm pretty jet lagged, so please bear with me if I'm a little bit slow this morning. So today we're going to be talking about LiveView and how you should be handling your async events. We'll talk about what they are, why you should care about them, and I'm going to give you guys a little story before we dive into some demos and show you guys how a product can evolve from being not so good at handling async tasks to being a lot better. I love building side projects and I love Elixir and LiveView, so I'm on Twitter or X as Code Staring, and I blog on my website if you want to hear more Elixir content from me after today. And a quick little shout out for my employer. So I work at Multiverse, a ed tech company based in London and New York. And we're all about creating a diverse group of future leaders by building an outstanding alternative to higher education through apprenticeships. 90% of our tech stack's in Elixir. We have lots of LiveView. And we became the first ed tech unicorn in the UK last year. So if anyone wants to hear more, then have a chat with me outside afterwards. OK, so I imagine a lot of you already know this, but let's just get everyone on the same page just in case. So what are we talking about when we talk about asynchronous tasks, right? Like on the slides here, you can see a very brief example of what you might consider in the real world. If you're making dinner, you could chop your vegetables, you could chop your meat, you could grill the meat, you could roast the vegetables, and then you could eat. Or you could chop the vegetables and roast them while you continue doing your other tasks, and then you eat at the end, and everything's a little bit more seamless. So in programming, an async task is a task that executes and delivers its results asynchronously, meaning that the task returns control to the caller immediately, and it doesn't block, right? So the operation continues in the background, and then typically the asynchronous task will then notify the caller somehow using an event handler or a callback or a promise, or depending on what stack you're in. They're everywhere, and they take up a lot of what systems have to think about these days in common like web development, for one thing. If you need examples, you can think of API requests, database queries, file input-output, or just expensive queries that might be running. The main thing to remember is that they should continue. They should allow your application to continue running without blocking anything, if you've written your code correctly. But it does introduce some complexity if you try and coordinate that. So let's address the asynchronous elephant in the room. So a few months ago, I was chatting to Chris McCord about Elixir conference talks, and he was very kindly helping me refine my idea for the talk and even with the brief. So thank you to Chris for that. And while we were chatting, he mentioned that async tasks in LiveView were a huge pain, and he wanted to create a primitive for handling them better in LiveView. And well, now they're here. If you went to the keynote the other day, you'll have heard about assign async, and I can't wait to start using it and refactoring a lot of my code to use it, but sadly, it's not a silver bullet. So one thing that assign async will not do is keep async tasks running if the LiveView that called them closed down, right? So this talk is going to cover a little bit about what it can do for you and also what it can't do for you. And the patterns that we're going to see here should also play nicely with using assign async or not using it. So just keep that in mind as we go. OK, so a little story, set the scene. It's kind of what inspired this talk. So a few months back, when large language models suddenly became all the rage and ChatGPT was going to take over all our jobs overnight, I got swept up into the hype, and I wanted to play with them. So for me, the best way to play with new technology and learn about it is to build something real with it. So over a weekend, I built a simple SaaS product. It was called MealMind. And the idea was that you could fill out a form based on your dietary requirements, your goals, your personal information, like height and weight, and things like that. And then the system would calculate how many calories you should be consuming to gain or lose weight. And then it'll provide you with weekly meal plans, recipes, and shopping lists. It was pretty cool. I did it in LiveView, and it wasn't that hard. But as I was building it, I ran into an issue with how I was using the OpenAI APIs. So I was using ChatGPT with GPT-4. And I'm a big fan of GPT-4. It's really good. But it can take a fair bit of time to actually give you what you want. Not if you're streaming the results down, like a lot of the chat applications that you've seen do, but I needed the result to be in a structured JSON format because I wanted to use it consistently and use it programmatically in my code. So it's already slow. And then if you try and turn it into JSON, it's even slower. I tried using GPT 3.5, which was a lot faster, but it ended up ignoring my commands after time to turn it into JSON. And thankfully, though, GPT-4 was a lot more obedient, even though it was slower. So I eventually received the response that I wanted, which was great. But if you recall, I just said that I wanted weekly meal plans, right? And weekly means 7. So that means 7 different calls to ChatGPT every time someone pressed give me a meal plan. So what was the result? Really bad user experience. So my UI was locked. It would take about 5 to 10 minutes for anyone to receive their meal plans. And they had just paid for them as well, so keep that in mind. Users wouldn't know when the results had finished. They wouldn't know if something errored. It just wasn't a very good experience. I don't have an early build of MealMine to show here, but I prepared some demos to highlight pretty much the exact same thing and how it how it evolved over time to add in some incremental steps to make it better. Before we get to the demos, though, it might be worth discussing just briefly why the impact of bad asynchronous tasks is so important to UX and why you should care about it for your users. There's lots of reasons, but here are the big ones that you'll probably want to care about. So alongside all of these on the slides, users expect seamless, fast experiences these days, right? Like mobile and web apps have set very high standards, and attention spans are lower than ever. Things like TikTok and Instagram Reels have helped just accelerate the impatience that people have today with modern web experiences. So making sure that your user feels like something is happening is more important than ever. It's so important that it could be the difference between retaining a user or gaining one instead of them jumping ship to the next best thing. And human psychology has been shown as well to distort our perception of time. So studies showed that a 3-second freeze on a web app might actually feel closer to 10 seconds in users' minds. And if you couple that in with graceless handling, you'll run into more support complaints. People think that nothing's happened. They might be on your case quite a bit. There was a study carried out by UX guru Jakob Nielsen, who showed that increased response times led to massive reduced user satisfaction and loyalty. And that ultimately had a big impact on conversion rates. And all these things add up. So smoothing them out pays massive dividends for your business, for you, and for your users. So everyone wins. So let's imagine we have a travel planning application that users can visit, and they get customized itineraries for their upcoming travels, right? And I've called it Slow Travel. And the Slow Travel developers have been kind enough to give us 3 buttons to fetch our data. You'll see up there, as well as a reset button. They all do the same thing. They get your itinerary, but one fetches in 500 milliseconds, one fetches in 5,000, and one fetches in 50,000 for the most patient customers. And the API is, by its nature, quite slow. So we've included a handy little tip widget down there so that users can browse tips about their destination while they wait. And anecdotally, I always think you should do something like this if you have something really long running on your app, because it means they can do something while they wait, it'll distract them, and it'll stop them from going on Twitter to complain about how slow your app is while they're on it. So first of all, let's see what the worst case of this implementation could be, right? And keep in mind, this isn't the best user experience, but it will work. And let's see what it looks like. This is synchronous. So video loads. Yep, so you see that I'm there, I'm hitting through the tips, and that works. And then you can fetch some data, click 500 milliseconds, and then some data appears, right? Let's have a very brief look at the code. So there's a really simple API here, one that just returns some arbitrary data after a delay that we picked. And we trigger the data fetch on a button press depending on the delay, and then we return that to the UI, which just shows some data. Very simple live view. So here's the actual live view itself. You click on a button. The template isn't shown here, but you click on a button, that triggers off this start async task, and then the result just goes to the client eventually. So look here what happens at the tip component. You'll notice that when you're fetching data for 5 seconds, it doesn't work, right? And that's because between the handle event triggering and the diff arriving from the server, the client's waiting for a response from the server of the WebSocket before it can actually do anything. So because it's waiting for that diff to render the change to the UI, nothing else is reactive on the page. So now your UI is just completely locked. So that's not good, right? Bad. Don't do that. So lesson 1, always respond to your events immediately to not lock your UI. That might have been obvious to a lot of you, but for some of you it might not have been. And there's a little bit more to see just from that simple demo as well. So let's go back and watch what happens if we try and wait for 50 seconds without responding to the event in the code, right? How many of you know what will happen? Any ideas? Time up. Refresh the page. Yeah, it'll crash. So LiveView needs a response from the handle event call within 30 seconds, or it'll time out waiting for a response. And that timeout isn't configurable in any way, and it shouldn't be, because if you're waiting more than 30 seconds for something to happen on your page after you click a button, then you probably want to rethink your UI. Sadly, I can't speed this up on the demo, because we actually have to wait for 30 seconds for it to break. But should almost be done. There you go, up there. So you'll see that. So it just breaks, right? Not good. So lesson 2, always keep in mind that long-running tasks are bound to your UI. So if they're bound to your UI, they can crash if they're longer than 30 seconds. So that just reinforces lesson 1. Just don't do it in the first place. Don't bind them. So let's look at actually fetching this asynchronously and letting our UI get back to the job while the backend takes care of the API request. The code's really similar to the last time, except there's some slight changes now. So first of all, we wrap our function in a task async call to kick off a separate process to fetch the data. When the async task finishes, we need to capture that response in the handle info callback. And we also need to call process demonitor to stop monitoring that task. So that way, we receive a message when we don't receive a message when the task process goes down. And because we've already got the result, we don't care about the exit message that will happen when the process exits. And keep in mind that because your live view is the caller of this function, we're still going to be binding the live view process to the new process that's been spawned. And we'll talk about that in a minute. So now when we kick off our async task, we can immediately respond from our handle event callback, which is what happens there. We trigger a loading spinner by setting a Boolean value. And it's not here, but there's a sign in the mount just to set the loading spinner up. So let's try it out. So you can use the tips. You hit 5 seconds. It's loading now. You can see a little indication. And you can still use the tips. So the UI has been saved. Now the interface has been unlocked, and the user can do something while the data is being fetched, right? And that's lesson 3. You should always show a loading state. If your user's kicked off an action, don't leave them hanging. And thankfully, this is how now much easier thanks to assign async, which is coming to Phoenix soon. And this will probably change how you do that in the first place when that releases. I'd say this is the absolute bare minimum of what you want to do. And this might be really obvious, but you'd be shocked to learn how many times you see this. You don't see this in code bases, and people just do things they do things synchronously to fetch these long-running tasks. So keep that in mind. But there's still 2 things to point out here, right? So in the demo, watch what happens when I refresh the page. Well, first of all, the data's gone because I haven't persisted the result, so that's not great. And secondly, watch what happens if I refresh the page after I kick off the result. Nothing. Nothing happens, right? So because each live view instance is a new process, by refreshing, I've killed the last one and started a new one. So the new process knows nothing about the previous one that triggered the API request. So any result that you just kicked off is now lost. So if you imagine that your system was token-based, and every time a user clicked a button, it would cost them money, right, or use up a token to execute one of these tasks, and then you've done this, that's pretty bad, because they've just lost their money and nothing's happened, right? And keep in mind that assign async won't solve this, right? As Chris said, assign async handles tasks on exit. So that might not be what you want, right? I mean, it might be what you want, which is it's a trade-off, right? You have to think about what you want. Maybe you do want the task to exit as soon as they close their browser, but maybe you don't. For us, we're going to operate with you want it to carry on. The good news is we can really easily fix part of this. So for the third demo, very similar to our last one, but we've made some slight adjustments to the context function when it kicks off the API request. When it completes, we just store the result in a database using a basic repo insert, right? So that shouldn't be too crazy for anyone that's used some Phoenix and some Elixir. And you can ignore the demo name here. It's just for me to be able to separate one demo from another that's coming up. So in the demo now, if I kick off the task, and the data has been fetched, and then I refresh the page, it's still there, right? Which is great. So the database is persisting all of our data now. And that means that if we destroy our live view process in between or create a new one by refreshing, the result isn't lost. I've also made a slight adjustment to the live view so that we check for the occurrence of the data when we mount the page so that it knows to fetch it and render it if it's already there. And that brings us to lesson 4. So persist the results of your synchronous calls to avoid duplicating work or severely angering your user base. Right? Like I said, no one wants to know that some action they just took a long time to execute because their laptop ran out of battery, just failed after they pressed your very expensive button. So now when we're fetching it, we're doing some persistence. People can refresh after it's finished, and they can see the results. For this to work, though, we've also had to slightly change how we're making our async calls, and it gives us another benefit. So instead of wrapping our API call in a task async function, we're now using a task supervisor, and we're calling async no link instead. Right? The big difference here is that when you're using a supervisor to start the async task off, it runs the task on a globally supervised process, and that's not linked to or dependent on the individual live view process that kicked that off. Right? Which means that when your live view shuts down, when the page is refreshed, for example, it doesn't terminate that task. Okay? So we're also taking note of the caller ID here, the PID process, sorry, and then we're manually sending that result back to the caller when we're done. You need to do this now because they're decoupled and the live view won't know anything about the task when it's finished, so you have to inform the live view that it's done. And remember that like a live view is just a beam process. If anyone was at Jason's talk on Wednesday, then you might have learned that. If not, you should check it out. And so just consider what would have happened if you implemented the database persistence that we just showed without this, and think about what would have happened if a user kicked off a task and then refreshed the page before it finished. Right? They'd just be sitting there indefinitely, because remember, they're refreshed, brand new live view process, so when the async task starts yelling that it's complete, there won't be a parent task there to listen to anymore. Again, this is something that assign async won't cater for. So if you're using it, then the process carrying out the event would be killed, and then no background work would continue to be done. And this might be what you want, right? It depends. It depends on the use case, depends on how you want your system to work. It's up to you to decide which is the right approach for you. So that's lesson 5. Use a task supervisor to decouple your async tasks. And just keep in mind that by deferring the task execution, you don't have to worry about which process kicked off that work, which can be useful even outside of LiveView, right? If something else kicked off the task and you want it to die, that's OK, because now it will just run. There's another issue here to address. So what if the user refreshes the page, the data has been fetched and it's persisted, but the user has no way of knowing that now because their new LiveView process has a new mailbox, so they're not going to be sent a message telling them that it's done. Well, for that, we're going to use PubSub. And for those of you who don't know, I'm going to do a 30-second run-through of what it is, even though I think it's been mentioned quite a few times during the conference, but give a little refresher just in case. So PubSub is Elixir's built-in publish-subscribe library for sending event notifications between processes. It acts like a message bus, so if you use RabbitMQ or Kafka or something like that before, then you might have an idea of what that is. So processes can subscribe to topics that they're interested in, and then publishers can broadcast messages to those topics. And this all happens using Elixir's built-in process messaging system, and the API is really nice. In our case, it's really simple to implement, which I'll show in a second. And since your live view is just a process, you can subscribe to a topic, meaning it can just react when things happen, which is great. So let's go to a demo and see what happens if we combine PubSub with the database persistence and see what it has to do with our user experience. So if we kick off here, and then we leave the page and come back after 5 seconds has elapsed, then our application now fetches the data synchronously, it persists the result, and it updates all the clients in real time. So refresh, waiting, haven't clicked the button since the refresh, and the data pops up, right? So that's the data from the previous live view that got kicked off. So in terms of implementation, the big difference now is that it subscribes to a topic that I've created after the connection's been established. And keep in mind that a topic can be a unique key per group or user or whatever you want, but for now I've just hard-coded it in. I've added a function called notify subscribers, which emits an event via PubSub once the data has been persisted, and then I just list them for that in my live view. And the result's pretty nice. It means that users can just be in any state and be kept aware of what's happening, right? And the good thing is that you can architect your code so that you might not even be on the same page that kicked off the task. You could be somewhere else, and then you could pop in a flash message, or something else could happen, whatever you want. But the point is now they're completely decoupled from the UI, and you can listen for updates wherever you are, right? So lesson 6 is use PubSub to keep your clients informed as you go. Makes the code easier. You don't have to manually deal with messages flying around, and you can do all of this regardless of where they are. And it also lets you think about the separation of concerns between what your UI might be doing and what your backend might be doing. You can kick off a backend task, and then you're essentially just shouting when you're done. And then so long as something's there to listen to it that you've set up in your UI, then it'll know about it and it can react accordingly. But it's also worth thinking about what happens when things go wrong, right? Which is also something that doesn't happen too often in a lot of code bases you might see. So I've added this toggle here to make our API fail because software crashes, dependencies might be down, and Elixir is all about letting things crash. So let's say it crashes. What should we do? Well, you should handle it, right? Like lots of developers just code for the happy path, which is optimistic, and it'll happen most of the time, hopefully, but not all the time. So something will eventually fail, so you should handle that. And thankfully, PubSub makes it really easy to do this, right? All you have to do is pattern match on a failure, and then emit a slightly different message when the call fails, and they just handle that in your live view. So when it succeeds, or when it's successful, I send the data fetched message. I stop the loading, and I set the results true. But when it fails, I send the data error message, I stop the loading spinner, and then I put a flash message instead. And you can do what you want to handle it, right? So lesson 7 is let it crash, but handle it gracefully. Tell your user what's happened and handle it. Kick off the task again, maybe let your user do something like let them kick off the action again. You could send an error report to your developers. You could ask for feedback. It's entirely up to you, but just make sure you do something about it, please. OK, so now we've talked about how to handle live view async tasks in Grace, but not in style yet, and that would be betraying the title of the talk. So let's look at the final demo. And this one's a bit of an added bonus. You don't really need it, but I feel like it can give your product quite a bit of nice polish, depending on how you choose to do it. And sometimes it captures your user's attention that's not paying attention anymore because they're scrolling through their phone. So let's see what it might look like. Luckily, LiveView makes it really easy to trigger animations thanks to things like LiveView.js or just setting props. And you can push events from the server. But in my case here, there you go, I've got a HTML attribute on the cards so that when they get set, the content triggers and then it appears in LiveView. And I've also got a keyframe animation that triggers off the back of that. I've also made a push event to a hook that I triggered to kick some confetti off firing as well. And that's the last lesson, right? Polish UX with CSS transitions and animations. It usually doesn't take a lot of time to implement this. This took maybe, to add that last bit in, took maybe 10 minutes or so. But that small pop of delight could be quite a big drastic to some users. People like shiny things, so you should make things shiny if you can. So let's just quickly recap those 8 lessons. So always respond to events immediately to keep your UI free. Otherwise, your long-running task could crash your live view if your tasks coupled. Always show a loading state to keep your users informed of what's going on. Always persist your async results to ensure you're not duplicating any work across those users. Use a task supervisor instead of firing off task async function calls inside your live view to make sure that your async task doesn't rely on that live view process persisting. Or don't, right? That's important too. If you want that to happen, that's fine. Maybe use assign async. Consider leveraging PubSub to publish events to your clients when your long-running tasks are completed. That way they can be kept informed regardless of where they are, what they're doing. Maybe send them an email. It's up to you. And don't just handle the happy path, right? Make sure you have a plan for when your async task fails and check you're doing something to help your user deal with it if something goes wrong. And then finally, consider adding a bit of polish and pop using some CSS animations or transitions or whatever you want just to spruce up the experience slightly. And that's it. If you've enjoyed the talk, I've recently released an ebook called the LiveView Cookbook, which is full of similar recipes and patterns for developing LiveView applications like this one today. I've added a QR code here for anyone that's interested, and there's a 15% off code running until Sunday if you put ElixirConf23 in the checkout. I also tweet a lot about Elixir, and I've started doing LiveView video tutorials on YouTube, at Code Stirring on Twitch as well, if you want to check me out there. And I'll put the code on GitHub if anyone wants to look at all the demos. There's 5 of them. Thanks for your time, and I hope you learned something. Thanks.